Alright, good afternoon and welcome to Mass Atoka online class. If today is the first time of watching our video, please click the subscribe button and turn on the notification bell so that YouTube will alert you anytime we drop a video like this, okay? So we are still in the third video in chemistry. We want to talk about mass, mole and volume, their relationship, okay? Now all these things are still the amount of a substance. So mass is the amount of a substance, but mass is measured in what? In gram or kilogram, okay? Mole is an amount of substance, but it is measured in mole. The SI unit does not have the E, it's measured in mole. While volume is the amount of substance, but it's measured in either cm cube or dm cube, okay? So that is that. Now the question now is, how do we get each of these? Let's talk about mole first. How do we get mole? We get mole from what? A balanced equation. The coefficient of a substance in a balanced equation is the mole, okay? For example, now if hydrogen reacts with oxygen to give you water, this is not balanced, but if we balance it like this, then what does it mean? It means that what? 2 mole of oxygen is reacting with 1 mole of 2 mole of hydrogen is reacting with 1 mole. There's nothing here, so it is 1 mole of oxygen to give us what? 2 mole of water, okay? To give us 2 mole of water. Another one is that Na2 plus H2 to give us ammonia, NH3. So to balance this, how do we balance this? Put 2 here, 2 times 3 6, 3 here, 2 times 3 6, then put, okay, it's balanced now. So what does it mean? That 1 mole of oxygen is reacting with 3 mole of hydrogen to give us what? 2 mole of what? Ammonia, okay? So that is that. Now let's talk about how to get mass. For mass, to get mass, we say that mass is the same as saying mole times molar mass. Just mole times what? The molar mass of a substance. It will help you to get what? The mass. Another way you can get the mass is by saying that mass is same as what? Volume. Volume in dm cube. Volume in dm cube all over 22.4. This 22.4 is Avogadro's constant. 22.4 times molar mass. Okay, so what does it mean? It means that mole is same as volume over 22.4. So another way to get mass again is that mass is same as what? Volume in cm cube all over 22,400 in cm cube. This one is dm cube, this one is cm cube, then times molar mass, okay? So another way to get mass is by saying that mass is number of substance all over Avogadro's number times molar mass, okay? Another way you can get okay, so that is that for mass. So let us get volume. Let's get volume. For volume, we will say that what? Volume, in fact from here we can get volume. Volume in dm cube is simply by cross multiply. So volume in dm cube, volume in dm cube is simply, let's cross multiply, is simply mass times 22.4 divided by the molar mass, okay? So the next one is volume again. Volume in cm cube, volume in fact volume in dm cube again is what? You know that mass over molar mass is mole, so it's simply mole times 22.4, okay? It's simply mole times 22.4. So another way to get volume is simply from here we can get amount of substance or number of particles all over the Avogadro's number. Times that 22.4. Okay, all of them are in DMQ. All of them are in DMQ. So the last one now, another way to get mole. Let's talk about mole now. Another way to get mole is that mole is equal to mass over molar mass. Mass over molar mass is a mole. Another way to get mole is by saying number of particles all over Avogadro's number. Okay? Another way to get mole is by saying volume in dm cube all over 22.4. Another way to get mole is by saying volume in cm cube all over 22,400, 22,400. Okay, so that is that. Now note, all these particles can mean atoms, molecules, or ion. It depends. Okay, so take note of that. The particles can mean atom, molecule, or what? Ions. So I can clean here. Let us solve some calculation to illustrate what we have written, or to make use of the formula. Okay, so let's go. The first question we are going to solve said, number 1, what is the mass of 5 moles of oxygen O2? Solution. Okay, we want the mass. Don't forget that mass is equal to what? Mole times molar mass. Mass is mole times molar mass. So how many mole do we have? We have 5 mole times the molar mass of oxygen. Don't forget that oxygen is what? 16. So the molar mass of this oxygen is what? 2 into what? 16. So which is what? 5 times 32, which is what? 160 gram. Okay, 160 gram. Very simple. So the number 2, they say how many atoms are present in 6.2 gram of magnesium. Okay, manganese, sorry. Okay, magnesium, sorry, magnesium, Mg. Okay. Now, solution. So we know that the number of mole we know that mole is the same as saying number of atom or number of particle. Number of atom all over what? Avogadro's number. Please, that 22.4 is not Avogadro's number. Avogadro's number is 6.02 times 10 to the power 23. Okay, so please don't forget that. So I have that the mole. How do we get the mole? Don't forget that mole is mass over molar mass. So let us get that first. To get our mole is written as mass over what? Molar mass, and is equal to what? The number of the atom all over what? Avogadro's number. So let us put everything. The mass they gave us is 6.2 all over. The molar mass, magnesium. The molar mass of magnesium is 24. Yes, I can remember. 24, okay, is equal to the number of atoms we are looking for. Number of the atoms, okay, all over. Avogadro's number is 6.02 times 10 to the power 23. Yes. So if we cross multiply, we are going to have that the number of atoms is what? 6.2 times 6.02 times 10 raised to the power 23 all over 24. This time this divided by this. So if you do that, you are going to get 1.6 times 10 raised to the power what? 23 atoms. 1.6 times 10 raised to the power 23 atoms. All right. So the next example, they said if the relative molecular mass of an element is not a whole number. Okay, sorry, not that. What? Where am I now? Okay, they said why is the relative atomic mass of any element not a whole number? Why is the relative atomic mass of any element not a whole number? It's because of isotope. Very simple. It's because of isotope. The next question here said the number of particles in 1 mole of chemical compound is what? Is Avogadro's number, please. The number of one particle, please note that the number of just one particle in one, the number of particles in just 1 mole of a chemical compound is equal to what? Avogadro's number. So Avogadro's number is the number of what? Particles in 1 mole of a chemical reaction. So take that, please write that. Note that the number of particles in 1 mole, just 1 mole of a chemical compound is Avogadro's number. Okay? How did we get that? We know that mole is simply number of what? Particles. And don't forget that particles can be atom, ion, or what? Molecule. So number of particles all over what? Avogadro's number. So they say that it's just 1 mole. 1 mole of that. So 1 is equal to what? Number of what? Particles all over what? Avogadro's number. So if you cross multiply, you are going to have the what? Avogadro's number is equal to what? Number of particles. So Avogadro's number is equal to number of particles when we have that what? That particle has what? Just 1 mole. 1 mole of a compound. Okay? So that is that. The next question said, let me write that down. The next question, I think question number 3 said a chip used in a microscope micrometer, contains 5.72 times 10 raised to the power minus 3 gram of silicon. Okay, then I say calculate the number of silicon atom in the chip. And they say that that silicon Si is equal to 28. Why Avogadro's number, or Avogadro's constant? Avogadro's constant is equal to what? 6.02 times 10 raised to the power what? 23. Don't forget that. 6.02 times 10 raised to the power 23 is Avogadro's constant, or Avogadro's number. Okay, this is a very simple question. So what do we do? Solution. We have that the number of mole is equal to what? Number of particles all over what? Avogadro's constant, or Avogadro's number. Okay, so a number of mole is certain as saying mass over what? Molar mass, and is equal to what? That number of what? Particles all over what? Avogadro's number. So the mass that I'm giving is what? 5.72 4.72 times 10 raised power minus 3 all over the number of mole there. So the molar mass is what? 28. The molar mass is 28 is equal to what? The number of particles present, the number of what? Silicon atom all over 6.02 times 10 raised power what? 23. So if you cross multiply, you are going to have the what? The number of silicon atom is equal to what? 5.72 times 10 raised power minus 3 times 6.02 times 10 raised power 23 all over 28. So if you do that, you are going to get approximately 1.23 times 10 raised power what? 20. 1.23 times 10 raised power 20 atoms. Okay, you see, very, very simple. Very, very simple. So the next one, the mass, number 4, the mass of 1 mole, of NH4 to CO3 is the number of 1 mole of this is dash. They now gave that our O is 16, our N is 14, and our C is 12, and our H is 1. Okay? The number of 1 mole of this is dash. Okay? The number of 1 mole of this. Okay, sorry, the mass of 1 mole of this. Okay, so first of all, we know that mass, we are looking for the mass. Mass is equal to what? Just mole times molar mass. Mole times molar mass. And they say that it's just 1 mole. So 1 times the molar mass of this thing is what? That is 2 nitrogen plus 8 hydrogen plus 3 carbon plus, sorry, just 1 carbon and 3 oxygen. So I'm having 1 times 2 into 14 plus 8 into 1 plus 12 plus 3 into 16. So if you do everything, you are going to just add everything, then times it by 1. You get the same thing. That is 96.0 gram. Okay, 96.0 gram is the correct answer. Let's continue. Okay, they said the number of atoms, number 5, the number of atoms present in 2.5 mole of triatomic. Don't forget the atomicity is 3. Triatomic gas, and it should be ozone. Triatomic gas is equivalent to what? Triatomic gas is equivalent to dash. Okay, so they say the number of atoms present in this. We know that mole is equal to what? Number of atoms, or number of substance, or number of elements, number of atoms all over what? Avogadro's number now. Avogadro's number. Okay, so this will now show us that the number of mole there is 2.5 mole. 2.5 mole is equal to what? Number of what? Atoms all over what? Avogadro's number is 6.02 times 10 raised to power 23. So if you cross multiply, you are going to have that what? The number of atoms is equal to what? 2.5 times 6.02 times 10 raised to power 23. So this will give you what? 4.5 times 10 raised to power 24 atoms. Okay, so the last question we're going to solve in this question number 6. Question number 6 said how many moles of oxygen would contain 1.204 times 10 raised to power 24 molecules. Okay, now this is very simple. We know that number of mole is simply amount of substance or an amount of particle. Okay, amount of particles all over what? Avogadro's number. Don't forget this formula. It's very, very simple. Avogadro's. So the number of mole is what we are looking for. So but the number of particles is the number of molecules there. That is the number of particles. Yes. So how many moles? Yeah, this is the number of particles. That is 1.204 times 10 raised to power 24 divided by Avogadro's number, which is what? 6.02 times 10 raised to power what? 23. If you do that, we are going to get 2 moles. 2 moles. Okay, so that is that. Let me take my time before we enter percentage by mass. Okay, percentage by mass. All right, let me just solve 2 more questions. Then in our next video, we'll now enter that percentage by mass. Okay, so the next question here said how many atoms are present in 6.0 gram of magnesium. Are present in 6.0 gram of magnesium solution. Okay, we know that very simple, that mole is equal to what? Number of atoms or particles all over what? Avogadro's number. And we know that they don't give us mole here, but they gave us mass. So we know that mole is then saying mass over molar mass is equal to what? The number of atoms all over what? Avogadro's number. Well, let us put everything. The mass is 6.0 divided by the molar mass of magnesium is what? Is 24. So I have 24 is equal to what? The number of atoms in that magnesium that I'm looking for. And Avogadro's number is what? 6.02 times 10 raised to power what? 23. So if I cross multiply, I'm going to have that the number of atoms is equal to what? 6.0 times 6.02 times 10 raised to power 23, now divided by what? 24. So if you do that, you're going to have 1.505 times 10 raised to power 23. Okay, very, very simple. The last question I'm going to solve. The last question I'm going to solve said calculate the number of mole of Na, sodium, in 2.3 gram of Na2 plus. 2.3 gram of Na2 plus. Okay, the number of mole. Solution. We know that mole is equal to simply mass over what? The molar mass. So the mass is what? 2.3 gram divided by the molar mass of this thing is 23. Don't forget, the molar mass of sodium is what? 23. So I have 0.1 mole. So thank you very much for watching. Please share to anyone that needs it. Subscribe, like, comment, and God bless you.